Hello students and good morning. So now I am doing class for class 12. The topic is integration by the method of substitution. So this is your continuation class, because in the last online class also we were doing the same topic, that is integration by the method of substitution. So let's do exercise 6a, same exercise, page number 351, 4 mark section from the book Higher Mathematics for class 12 by Sailendra. So let us integrate this question number 18. The question is integral of x into, it is cube root of x plus 2 dx, right? So let us write it first as, therefore this is I is equal to integration of x into, so how will you write down this cube root? Cube root means x plus 2 whole to the power 1/3 dx. Okay, so now since this is the case of method of substitution, we can assume this x plus 2 as z. So let us assume, let z is equal to x plus 2. So let us differentiate both the sides with respect to x, differentiating both the sides with respect to x. Okay, so therefore this is dz by dx is equal to, differentiation of x with respect to x is 1 and for 2 it is 0. Now you can cross multiply, so dz is equal to dx. So it is cross multiplied, right? So what does I become now? I is equal to integral sign. Now you have to express this x in terms of z. So how can you get the value for x? We can get the value for x from this method of substitution. That is, if z is equal to x plus 2, what is the value for x here? So it is x is equal to, this is z minus 2. So what is the value for x in this case? It is z minus 2, right? So let us put it in I. What is the value for x? It is z minus 2 into, what is the value for x plus 2 now? It is z. It is z to the power 1/3. Z to the power 1/3 into dz. So is that understood now? So now you can multiply these two factors and you can separate integral sign also. So therefore I is equal to integration of, now we can multiply these two, z into z to the power 1/3. If we multiply z into z to the power 1/3, the powers will be added, that is z to the power, it will be 1 plus 1/3. Then you can write here dz. Okay, that is, it is z to the power 1 into z to the power 1/3. If these two z are multiplied, powers will be added, that is, it will be z to the power 1 plus 1/3. Okay, so what is the next integration? It is minus 2 integration of, because 2 is constant here, so it is written in front of integral sign. So minus 2 integral of, then z to the power 1/3. So it is z to the power 1/3 dz. Understood now? So let us simplify it further, or I is equal to integration of, this is z to the power 1 plus 1/3 is 4/3 dz minus 2 into, what is integration of z to the power 1/3? You know that this is z to the power 1/3 plus 1 divided by 1/3 plus 1. Then you can write plus c. So you know the integration of x to the power n dx, that is x to the power n plus 1 divided by n plus 1. Okay, so or I is equal to, this is z to the power, this is 4/3 plus 1 divided by 4/3 plus 1 minus 2 into z to the power, what is 1/3 plus 1? It is 3 ones are 3 plus 1. It is 4 by 3 divided by 4 by 3. Then it is plus c. Or I is equal to, this is z to the power 7 by 3 divided by 3 ones are 3 plus 4 is 7 by 3 minus, so it is 3 divided by 2, isn't it? You can cancel it. So it is 3 by 2. You can put the value of z now. So you can put it in the next step. It is plus c. Now put the value for z. What is the value for z in this case? Actually, the value for z is x plus 2. Again, you have to write down the answer in terms of x, not in terms of z. You can put the value for z here. Or I is equal to, this is, when this 7 by 3 goes up in the numerator, it becomes 3 by 7. What is the value for z? It is x plus 2. It is x plus 2 whole to the power 7 by 3 minus 3 by 2 into, what is z again? It is x plus 2. So it is x plus 2 whole to the power 4 by 3 plus c. So this is the final answer. So you can copy it. We'll do the next question now. Now let's do the next question, that is question number 19. You have to evaluate this integral of 2x minus 5 within bracket, then within square root it is 2x plus 1 dx. Okay, so therefore let us write here I is equal to integral sign 2x minus 5 root over, it is 2x plus 1 dx. So how will you do it? The expression under square root can be assumed as z, but in this case square root is in the numerator, so no need of assuming it as z square. So you can assume it as z square if the square root is in the denominator. If the square root is in the denominator, we could have assumed this 2x plus 1 as z square, but since it is in the numerator, don't assume it as z square, just assume it as z only. Okay, so let it is z is equal to 2x plus 1. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what does it become now? So it is dz by dx is equal to 2. Okay, now you can do cross multiplication. So dz is equal to 2 dx. Or you can take this 2 to the left hand side, so dz by 2 is equal to dx. That means we have got the value for dx. Again there is 2x here. You have to express this 2x in terms of z. So from here you can get the value for 2x. Okay, what is the value for 2x from here? It is z minus 1. So what does I become now? Therefore I is equal to integration of within bracket. So instead of 2x, what should we put? Z minus 1. It is z minus 1. Then write down minus 5. Then it is root over z. Root over z into, what is dx here? It is dz by 2. It is dz by 2. Okay. So now we can simplify it further. Therefore I is equal to, which constant is taken outside now? It is half. So this is half integral of, then within bracket we have z minus 6. It is z minus 6 into, what's about root over z? It is z to the power half. It is z to the power half. Then you can write dz. Understood now? So let us simplify it further. Now you can multiply it. Half integral sign z. This is z into z to the power half. If you multiply these two z, powers will be added. So it will be 1 plus half. Then you can write dz. Okay. So we are separating this integral sign in dz also. So there is minus sign here. Minus half into 6 is 3. 3 integral sign. This is z to the power half dz. Is that clear now? So let us simplify it. Or I is equal to half into integration of, this is z to the power 1 plus half is 2 and the 2 plus 1 3 by 2 dz minus 3 integral sign, this is z to the power half dz. Now you can easily integrate them. So what is integration of x to the power n dx? It is x to the power n plus 1 divided by n plus 1. Okay. So or I is equal to, this is half into z to the power, what is n plus 1 here? 3 by 2 plus 1. What is 3 by 2 plus 1? it is 5 by 2 divided by 5 by 2 minus 3 into, what is integration of z to the power half? It is just like your x to the power n. So it is x to the power n plus 1 divided by n plus 1. So this is z to the power half plus 1 is 3 by 2 divided by 3 by 2, then plus c. So we can cancel here. This 2 gets cancels. Here this 3 gets cancels. So or I is equal to, this is your 1 by 5. So what is the value for z here? Here z is equal to 2x plus 1 is there. So you can write here 2x plus 1 whole to the power 5 by 2. Then minus 2 is here. 2 into, what is the value for z again? It is 2x plus 1. So it is 2x plus 1 whole to the power 3 by 2 plus c. So this is the final answer. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 20. You have to integrate integral of 2x minus 1 divided by x plus 1 whole square dx by the method of substitution. So therefore I is equal to integration of 2x minus 1 divided by x plus 1 whole square dx. So how will you do it? So what is the method for integrating it? So we can assume this x plus 1 as z, so that after differentiation you can get the value for dx. So let us assume this x plus 1 as z. So let z is equal to x plus 1. Okay. So now you have to differentiate it. If you do the method of substitution in integral, you have to differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore this is dz by dx is equal to, what is d by dx of x? It is 1, and for 1 it is 0. So it is only 1. So if you cross multiply it, you will get dz is equal to dx. So I think you have understood it. But in this case we have put x plus 1 as z. But again here there is x in the numerator. So you can express this x in terms of z. So if this x plus 1 and dx are expressed in terms of dz and z, you have to express this x in terms of z also, which is in the numerator. So from here you can get the value for x. What is the value for x from here? It is z minus 1. So x is equal to z minus 1, right? So therefore I is equal to, this is integration of 2 into, what is x here? X is z minus 1, bracket closed. It is the value for x, that is z minus 1. Then write down minus 1. This whole divided by, what is x plus 1? It is z square. And what's about this dx? Dx is, you can write it as dz. Now let's simplify the numerator now. So therefore I is equal to integration of, now multiply by 2 here, 2z minus 2. This is 2z minus 2. Then minus 1. Minus 1 whole divided by z square, then dz. Okay. Or I is equal to, this is integral sign 2z minus 2 minus 1 is 3 whole divided by z square dz. Is that understood? Now you have to separate this expression. Or I is equal to integral sign within bracket. What is 2z by z square? You know that this is 2 by z. Minus 2z by z square is z, and square will be cancelled. We will get 2 by z. And minus, this is 3 by z square. Bracket closed. Then you can write dz. Now we can separate the term. Or I is equal to 2 integral sign 1 by z dz minus 3 integral sign. It will be 1 by z square. But z square can be taken to the numerator. it will be z to the power minus 2. So n can be minus 2, but you cannot take this z to the numerator. It will be z to the power minus 1, and if n is minus 1, it is meaningless. You cannot get the integration of x to the power minus 1. So you have to keep it as it is. That is 1 by z dz. Okay. So here only you can take this z square to the numerator. So it becomes z to the power minus 2 dz. Okay. Or I is equal to 2 into, what is integration of 1 by z? Or differentiation of which function is 1 by z? It is log within mod z. So integration of 1 by z is log within mod z base e minus 3 into, it is just like your x to the power n. What is integration of x to the power n? It is x to the power n plus 1 divided by n plus 1. But here it is z to the power minus 1 divided by minus 1. Then what do we write? Plus c. Okay. So, or this is I is equal to 2 log within mod z base e minus into minus. You can cancel this minus sign. Minus into minus is plus actually. So it is 3z to the power minus 1 is taken to the denominator. So it becomes 1 by z and it is plus c. So you can put the value of z now. Or I is equal to 2 log within mod. What is the value for z? Actually the value for z is x plus 1, right? So it is x plus 1 base e plus 3 divided by, what is the value for z again? It is x plus 1. It is x plus 1, then you can write plus c. So this is the final answer. So this question is very, very important. So you can mark it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 21. Here given is integral of, you have to find out the integral of x dx divided by a plus bx. So let us first write down I is equal to integration of x dx divided by a plus bx. So for this expression I already told you about the method if the expression is x divided by a plus bx. So in this case, what is the highest power of x in the numerator? In the numerator, the highest power of x is 1. And what is the highest power of x in the denominator? It is also 1. A plus bx is there. So what is the highest power of x in the denominator? That is also 1. So if the highest power of x in the numerator and the denominators are same, I told you the method about this. So if the highest power of x in the numerator and the denominators are same, whatever is there in the denominator, write it in the numerator. त मैले तिमीलाई यसको मेथड भनिसकेको छु. यदि हाईएस्ट पावर अफ x इन द न्यूमरेटर र हाईएस्ट पावर अफ x इन द डिनोमिनेटर सेम छ भने डिनोमिनेटरमा जे छ हामी त्यही न्यूमरेटरमा लेख्छौं. ठीक छ? दैट इज a plus bx चाहिँ हामी केमा लेख्छौं? न्यूमरेटरमा लेख्छौं. ठीक छ? So therefore let us write a plus bx in the numerator and let us keep it within bracket. But there is only x, but here we have bx. So how can you make this bx as x only? You have to divide it by b, isn't it? If this b is multiplied by 1 by b, 1 by b into b, bb will cancel, bb will be cancelled and you will get x only. So you have to divide this a plus bx by b. Is that clear? So if you multiply this bx by 1 by b, this bb will be cancelled and you get x. That is correct, x is correct. But there is only x. So if you multiply a by 1 by b, you will get a by b. Is there a by b in the numerator? No, you have to cancel it. So it is minus a by b. So I think you have understood it now. So whole divided by this is a plus bx. Then what do we write here? dx. Is that clear? So now let us separate this expression. Or I is equal to integral sign within second bracket. So now you can separate this fraction. So how can you separate this fraction? The numerator will be 1 by b into a plus bx divided by a plus bx. This a plus bx will be cancelled and you will get 1 by b only. Then minus sign is there. So it is a by b divided by a plus bx. So now it is, that is a by b divided by a plus bx. So here second bracket is closed and then you can write dx. I think you have understood it. So now you can separate integral sign and dx. So now it becomes I is equal to, what is the first term in this case? So 1 by b is constant, it is taken outside, integration dx. Then comes minus sign. Again a by b is constant, it is taken outside, integral sign. So whenever you have a constant term, you can take it outside, integration. And now we have, it is dx divided by a plus bx. I think you have understood it. So now, or this is I is equal to 1 by b into, what is integral sign, dx, that is your x, minus a by b into, now how will you integrate this dx divided by a plus bx? Now in this case the power of x is 1. So a plus bx you can take it as x. So it is just like your dx by x, isn't it? So what is integration of dx by x? It is log x. But here x is a plus bx and here the base is e. But which function is taken as x here? That is a plus bx is taken as x here. Then we have integrated it as integral of 1 by x dx and we have written down here log of a plus bx base e. But again you have to differentiate the term which is assumed as x. Here a plus bx is assumed as x. So what is this differentiation? For a it is 0 and for bx it is b. So 0 plus b is always b. Is that clear? So in case of differentiation you have to multiply it by b, but this is the case of integration. So you have to divide it by differentiation of a plus bx with respect to x, that is b. You should divide log of a plus bx base c divided by the differentiation of a plus bx with respect to x, that is b. Then you can write here plus c. So or it is I is equal to, this is x by b minus a by b square log within mod a plus bx base e. Then you can write plus c. So this is the final answer. So this question is also very, very important. So you can mark it. So now we can copy it. Now we'll do the next question now. So now let's do the next question. That is, you have to evaluate integral of px dx divided by cube root of qx plus r. So in this case also you can assume this qx plus r as z. So before that, this cube root of qx plus r can be written in terms of qx plus r whole to the power 1/3. So let us write here I is equal to integral of px dx divided by, this is qx plus r whole to the power 1/3. So in this case also let us assume, let us do the method of substitution. We can assume this qx plus r as z. So in this case pq and r are constant. Okay, so let z is equal to qx plus r. So let us differentiate both the sides with respect to x. Differentiating both the sides with respect to x. Okay, so therefore this is your dz by dx is equal to, it is only q. For qx, what is the differentiation of qx with respect to x? That is q. And for r it is 0. So let us cross multiply it. So dz is equal to q dx, or now this is dz upon q is equal to dx. That is dx is equal to dz upon q. Okay, now we have got x out here. So from here you can get the value for x. You know how to get the value for x from here. So what is the value for qx first? It is z minus r. Is that clear? Now what is the value for x from here? X is equal to z minus r, this whole divided by q. Understood? So what is the value for x from here? It is z minus r whole divided by q. So let us put it in I. So therefore I is equal to integration of. So p remains as it is within bracket. What is the value for x? It is z minus r by q, bracket closed, whole divided by, what is qx plus r? It is z. So it is z to the power 1/3. And what's about dx? Dx is dz by q. So here you can write it is dz divided by q. Understood? So let us simplify it first. Therefore I is equal to, so which constant is taken outside? It is p. P is constant here. So it is p divided by, this q and q are in the denominator. You can multiply them. So q into q is square. So it is integral of, in the numerator we have z minus r whole divided by, that is z to the power 1/3. It is z to the power 1/3. Then what can you write? You can write dz. So you can separate the term in this case, or I is equal to, so p by q square integration of within bracket. So let us separate the term here. So it is z divided by z to the power 1/3 minus r divided by z to the power 1/3, bracket closed. It is dz, or I is equal to p by q square integration of within bracket z to the power, so 1. It is z to the power 1. So when this 1/3 goes up in the numerator, it becomes minus 1/3 minus r into z to the power, this is minus 1/3, bracket close, dz. That is z to the power 1/3. It becomes z to the power minus 1/3 in the numerator. Okay. So now we can separate the term. So it is p by q square integration of z to the power. What is 1 minus 1/3? 3 ones are 3 minus 1 is 2 by 3 dz minus, this r is constant taken outside, so it is pr by q square, pr by q square, then it is integral sign, so it is z to the power minus 1/3 dz. I think you have understood it. So let us simplify it. Let us use the formula. I is equal to p by q square into, what is the integration of z to the power 2/3? So this will be z to the power 5 by 3 divided by, this is 5 by 3. That is 2/3 plus 1. X to the power n plus 1 divided by n plus 1. So it is z to the power 2 by 3 plus 1. That is 5 by 3 divided by 2 by 3 plus 1. That is 5 by 3. Okay. So minus pr by q square into z to the power minus 1/3 plus 1 divided by minus 1/3 plus 1. What is that? 3 ones are 3 minus 1 is 2/3. So this is also 2/3 plus c. Okay. So the final answer now is I is equal to, this is 3p divided by 5q square, right? So 5 by 3, when it goes up in the numerator, it becomes 3p divided by 5q square. Put the value of z. What is z? It is qx plus r. It is qx plus r whole to the power 5 by 3 minus, what is the second term? This 2 by 3, it becomes 3 by 2 in the numerator. So this is 3pr divided by 2q square, right? 3pr divided by 2q square. What is the value for z again? What is the value for z again? It is qx plus r. So here you can write, this is qx plus r whole to the power 2 by 3. Then you can write plus c. So this is the final answer. So now we can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 24. You have to evaluate this integration of dx divided by x plus root x. So let us find out this integration. So let us write first I is equal to integration of dx divided by x plus root x. Now let us remove square root from the second term, that is root over x. From this root over x, let us remove this square root by the method of substitution. So what should you put for x in order to remove square root? Let us put x is equal to z square. So we can put it, isn't it? So let x is equal to what? Z square. Since we are doing the method of substitution in this case, you have to differentiate both the sides with respect to x. So before substitution, x is the variable. Before substitution, x is the variable, and after substitution, which is the new variable here? It is z. So let us write here differentiating both the sides. Differentiating both the sides with respect to z. So this is dx by dz is equal to 2z. You can do cross multiplication. Dx is equal to 2z dz. So here dx is equal to 2z dz. Is that clear? So let us put it in I. Therefore I is equal to integration of what is dx? Here dx is 2z dz whole divided by, in the denominator, what is x? It is z square plus what is root over z square. Now x is z square here, so what is root over z square? That is your z. Okay, so here therefore I is equal to, which is constant here that you can take outside, that is 2 is constant. So 2 integral sine z dz divided by, in the denominator what is common? You can take common. Z is common here. So z is common within bracket z plus 1. Is that clear? So here you can cancel this z. So or I is equal to 2 integral sine, this is dz divided by z plus 1. So now you can directly integrate it. What is the power of z here? Power of z is 1. And since this is an algebraic expression, you can take it as z. Z plus 1 is taken as z. What is integration of dz by z? It is log z, right? So or I is equal to 2 log within mod. What is z here? It is z plus 1. The base is z. Now we have to again differentiate the term which is assumed as z. That is, again you have to differentiate z plus 1 with respect to z, which is equal to 1. So you have to divide it by 1 in case of integration. In case of differentiation, you have to multiply by the differentiation of z plus 1 with respect to z, it is 1. But this is the case of integration, so you have to divide it by the differentiation of z plus 1 with respect to z, which is 1. Since this is 1, you don't have to write it, okay? So this is the final answer. But you can put the value of z. You have to put the value of z, okay? Don't leave the answer here. If you leave the answer here, if it carries 3 marks, 1 mark will be deducted if you don't put the value for z here. Okay, so what is the value for z here? So if z square is equal to x, what is the value for z? It is root x. So or it is I is equal to 2 log within mod. What is the value for z? It is root over x. Then it is plus 1 plus c. Here the base is e. So this is the final answer. So I think you have understood it. You can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 25. Let us integrate this integral of dx divided by root over x minus 1. So in this case also same method is used as we have done in question number 24. So root over x is there. Let us put x is equal to z square here also. Okay. So therefore I is equal to integration of, let us first write down this. I is equal to integral sine dx divided by root over x minus 1. Now we have to remove square root from x. Remove square root from x. So we can put let x is equal to z square. So differentiating both the sides with respect to x, or you may write with respect to z also. So it will be dy dx of x is equal to dy dx of z square. You may write differentiating both the sides with respect to z, or you may write differentiating both the sides with respect to x also. So what is dy dx of x? That is 1 is equal to, what is dy dx of z square? It is 2z into dz by dx. Now let us do cross multiplication here. So dx is equal to, this is 2z dz. Is that understood now? So let us put these values in I. So now I becomes, I is equal to integral of, what is the value for dx? 2z dz. So it is 2z dz divided by, it is 2z dz divided by, what is root over x square? It is root over z square. What is root over z square? This is z minus 1. So which constant is taken outside? 2 integral sine z dz divided by z minus 1. Is that clear now? So now in this case, you know the method how to simplify it or how to integrate it. So in the numerator, what is the power of z? It is 1. And in the denominator, what is the power of z? That is also 1. So the highest power of z in both the numerators and the denominators are same. So what is the method here? Whatever is there in the denominator, you have to write it in the numerator, right? So or I is equal to 2 integral sine, this will be z minus 1. Okay, so z is correct here. So minus 1 is also there, but is there minus 1 here? So there is no minus 1 here, you have to cancel it. So you have to write down plus 1 whole divided by z minus 1. Then what do you write? dz. ठीक छ? So यहाँ z को हाइएस्ट पावर 1, तल पनि z को हाइएस्ट पावर 1 छ भने तल डिनोमिनेटरमा जे छ हामी माथि त्यही लेख्छौं. That is z minus 1. So z is correct here, but is there minus 1 here? No. So you have to cancel it. So write down plus 1 whole divided by, it is z minus 1 dz. Now you can separate this term. Okay. So or I is equal to 2 integral of within second bracket. What's about z minus 1 divided by z minus 1? It is 1. Plus next, it is 1 upon, this is your z minus 1 second bracket closed dz. Understood? Now you can separate the term. Or I is equal to 2 integral sine dz plus 2 integral sine dz divided by z minus 1. Now you can easily integrate them. Or I is equal to 2, what is integral sine dz? That is your z plus 2 into, how can you integrate this dz by z minus 1? Here the power of z is 1. So you can take this z minus 1, since it is algebraic function, this z minus 1 can be taken as z. So what is integration of 1 by z dz? It is log z. So it is log within mod z minus 1. Actually you have to divide it by 1 also, because z minus 1 is taken as z to integrate it. Again you have to differentiate the term which is assumed as z. That is, what is the differentiation of z minus 1 with respect to z? That is 1. So in case of differentiation you have to multiply it by 1, but since this is the case of integration, you have to divide it by 1. So since this is 1, dividing by 1, you don't have to write that 1. Okay, so write down plus c. So let us put the value for z. Or I is equal to 2 into, what is the value for z? Since z square is equal to x, what is the value for z? It is root x. So z is root x plus 2 log within mod, what is z? It is root over x minus 1 mod sign closed plus c. So this is the final answer. So I think you have understood it. So this question is also very, very important. You can mark it. Okay, so you can copy it. So this much is for today. So we have done some problems today. So you revise all the problems, and You can revise all the problems that we did so far in this method of substitution. In the next online class, we'll do more problems on this chapter. So this much is for today.